All right, here for number 8, we have a man that is hitting the ground with a speed of 6.4 meters per second. Since that's downward, I'm going to call that negative 6.4 meters per second because we're going to be dealing with change in momentum, which means it's a vector quantity, and we'll want to think of upward force as being positive. I think it'll make things a little bit easier. So we have 75 kilogram man just before he makes contact with the ground, and 2 milliseconds is 2 times 10 to the negative third, 2 times 10 to the negative 3 seconds. So the average net force. So based on what we did just a second ago, we know that force, here, I'll just go ahead and do it here. We know that force times time is equal to delta mv. All right, so that means that the average force is going to be equal to delta mv over t. All right, so since we have, it's actually mass times delta v, because the mass isn't going to change, the velocity is. So now we'll put in the mass, which is 75 kilograms. 75 kilograms times delta v, which is v final 0, minus negative 6.4 meters per second. That'll give us a positive, of course. And then we had 2 milliseconds, which is 2 times 10 to the negative third seconds. All right, just like we did in problem a few minutes ago, or maybe you didn't look at it, but a few pages back. Kilogram meters per second, kilogram meters per second squared. That's newtons, so that's force. So now, crunching these numbers, we get a crazy amount of force. This force here is equal to 2.4 times 10 to the 5th newtons. That is bone-shattering. So now looking at part B, which I'll do in blue, B for blue, blue for B, we get, it asks what would the force be if he bent his knees, and in this case, T was equal to 0.1 seconds. We could plug it in all up like we did up here, or we can recognize that 0.1 seconds is 500 times 2 milliseconds, right? Because this is 100 milliseconds. Whoops, 100 milliseconds. So not 500, but 50. Before it was 2 milliseconds, now it's 100, so it's 50. So it'll be 1/50th the force. So we could say 2.4 times 10 to the 5th over 50 is going to be much smaller. That's going to be equal to, let's see, 4.8 times 10 to the 3rd newtons. You can yell at me later for using a value that I already calculated to do that work. But considerably less force. Still, that looks like it might be painful, but considerably less painful than 240,000 newtons. All right, next we're asked to find what the force is exerted by the ground. It's important to recognize that this right here is the net force. So if the net force is equal to the force exerted upward by the ground, right, plus the force exerted downward by gravity, that vector, or those vectors, would look like this. This is 240,000 newtons. Can't you imagine that mg, which is roughly 750 newtons, right? Because he's 75 kilograms, and I'm just estimating here. Just trying to give you the idea that in terms of the value that we have here, right here, 2.4 times 10 to the 2.4, times 10 to the 5th newtons. If we're just talking about 750 newtons, that's not even within the sig figs. That's just going to get eaten up by our precision anyway. So it's not really even going to change if we use the same precision, that is 2 sig figs. So the answer to part C here, part C1, if you will, is still going to be 2.4 times 10 to the 5th newtons. Okay? But now if we do it the other way, and we've got, let's see, 4,800 newtons here, and 750 newtons pointing down, again, that's still just an estimate, 750 newtons. I'm sorry, this is the net force. So we're trying to find the force exerted by the ground right here. We know that the net force is equal to 4,800 newtons. We know also that the net force is equal to force exerted by the ground. I'm going to say E for the Earth because F sub G are usually reserved for gravity. Whoops. Minus the force of gravity, minus 750 newtons. Again, you can yell at me for not doing this algebraically. You can do that later. All right, that means that 4,800 newtons is equal to force of the Earth minus 750 newtons. So now this is within the range of our sig figs, because now we're going to add 750, so we get 5550 newtons is equal to the force exerted by the Earth. So if we go back to 2 sig figs, we say that the force exerted by the Earth is equal to 5.6 times 10 to the third newtons. Again, that's positive, an upward force exerted by the ground. Of course, now I've gone back and looked at it. If we actually use 9.8 instead of 10, instead of that estimate, then that would round down. So this would actually be 5.6 times 10 to the third newtons. I'm not really worried about that, as long as you understand conceptually that the force exerted by the Earth is going to be greater than the net force, because we also have to consider the force exerted by gravity.